Welcome to a lesson with Dr. Powell. Let's take a look at a way that we can come up with the equation of a tangent plane for a surface. Suppose, for instance, that we have a surface f of xy is equal to 3x squared minus 4y squared. And we would like to find the equation of the surface associated with the point 1, 0. Okay, so what is the tangent? What's the tangent plane here? Well, if we can compute the derivative of this function, fx, fy, and thinking of it as a gradient vector, then to find out how much you find the rise of the tangent plane, of the z value of the tangent plane from this point, we simply compute a dot product. Let's suppose that we're going to the point xy. So we start at the point 1, 0. Let's go to the point xy. So that's our run. Our run would be the difference of these 2 points, x minus 1, y minus 0. And if you compute this dot product, you actually would end up getting the rise of the tangent of the z value of the tangent plane from that point. So let's figure out what that rise is. Now, in this particular case, we should evaluate fx and fy, but we should not only evaluate it or compute it, but we should plug in the point 1, 0 because we're looking for the gradient at the specific point of input. So we compute fx, fy, and we end up getting 6x, negative 8y. So that's the gradient as a function, but we're going to plug in the point 1, 0, finding the tangent plane from that point. So the derivative of the at 1, 0 is, and we get 6, 0. That would be like the derivative. So we can put a 6, 0 in here. We compute this dot product, and we end up getting 6 times x minus 1. That represents the rise. So how do you get the z value of the tangent plane? Well, you get basically its start plus rise from start. It's like the starting z, where z starts plus the rise of z from the start. It's a lot like, in fact, if you look at this, think of this derivative as slope. Think of this input as like x. It looks like an mx plus b type thing all over again. It's kind of nifty, but that's really all it is. So we got to find our starting z value. Our starting z value is the value of z, or the output of the function here, at 1, 0. So we can stick 1, 0 in here, and we end up getting 3. So our starting z value is 3, and our rise from the start to the point xy is simply plus 6 x minus 1. Okay, so that's it. That's the equation of the plane. In this particular case, it's just z is equal to 3 plus 6 times quantity x minus 1. So z is equal to 3 plus 6 times x minus 1. And that's it. That's the equation of the tangent plane at the point 1, 0. Thanks for watching.